Guys, have you seen that poster from our college?
Which poster?
Poster about the Go Green campaign. They make a competition, a TikTok video competition. Do you guys want to join?
Why not?
Yes, can!
And hi everyone, have you watched the previous video and wondering how that trash can be thrown into the dustbin? So today our group will make a clear justification on how dynamics on that trash can happen. This real life case study is related to our assignment on KIB1006 dynamic subject. So first thing first, let's look at the brief introduction on what dynamic is. Okay, so what is dynamics? Dynamics is the study of system in which the motion of the object is changing, which means this object is accelerating. There are two major analysis techniques that explain what dynamic actually is, which are kinematics and kinetics. Kinematics is the geometric aspect of motion such as position, velocity, and acceleration, while kinetics is the force that causes the motion to happen. And somehow it is related to energy and momentum. In this video, our group will be explained on how to solve dynamics problem of accelerating particles, solving problems of accelerating rigid bodies in two dimensions, and analyzing kinematics and kinetics problem in vibrating particles.
And 01. Solve dynamic problems of accelerating particles. After the girl threw the object into the dustbin, we know that the initial displacement for both x and y axis is equal to 0. A refers to the position of the object, where x-axis 4.5 meter, y-axis negative 2.3 meter. The initial velocity v0 has two components, x and y, along the horizontal and vertical. Here we can resolve the initial velocity to x-axis and y-axis, resulting the v0s is equal to v0 cos 70 degree. v0y is v0 sin 70 degree. By using this equation and insert all the values into this equation, we will get the first equation where t equals to 4.5 over v0 cos 70 degree. The second equation that we will use is this equation. We will get the second equation. Insert the first equation into this second equation. We will obtain the initial velocity, which is 7.609 meter per second. After that, we know that Vx is equals to V0x, resulting 2.602 meter per second, while V0y is equals to 7.15 meter per second. In order to obtain the velocity in y direction, we will use this equation by assuming the positive is up, which is Iy equals to negative g equals to negative 9.8 meter per second square. We will obtain the value of Vy equals to 9.81 meter per second. The value of the resultant velocity can be obtained by using this equation. After inserting the value of Vx and Vy, you will get value of velocity, which is 10.15 meter per second. By inserting the Vy and Vx into this equation, we will get the value of direction or angle of velocity, which is 75.14 degree.
Okay, now I will continue with LO2, where we will discuss on how to solve the problems of accelerating rigid bodies in 2D. This FBD is the FBD of the trash that were thrown away. The arrow downward is W, which indicates the weight of the trash, and also W is equal to mg. And this arrow is the V, which indicates the velocity of the trash that when it was thrown away at 70 degrees from the x-axis. Okay, then we're going to see the conservation of energy when it happens during the projectile motion when we throw the trash into the dustbin. The mass of the trash is 0.25 kilogram. The distance of the trash radius from the ground is which is h is 2.3 meter. V0, which is the initial velocity, is 7.609 meter per second. V1, which is the final velocity, is 10.15 meter per second, where the final velocity is where we got from the LO1. The law of the conservation energy is T naught plus V naught, which it indicates uh, the the initial where we start throwing the trash is equal to T1 plus V1, where the T1 plus V1 indicates the final energy when the trash get into the dustbin. And from the formula given, we insert the value into the formula, and the left hand side, which is the initial, we calculate it, and the energy for the initial is 12.878 joule, while the right hand side, which indicates the final one, we calculate it, and we also get the same energy, which is 12.878 joule. This indicates the left hand side is same with the right hand side, which is 12.878 joule, and this indicates the energy is conserved when we throw the trash into the dustbin. That's all for the LO2.
So we're going to proceed into the next learning outcome, which is LO3, analyzing kinematics and kinetic problems in vibrating particles. So what we're going to do here is actually we're going to do an impact analysis on the case study that we've chosen. As you can see in the earlier part of our video, my friend threw an object into the bin. So what happened to the object after it hits the ground? So what actually happened is the object will bounce off the ground a little bit when it hits the surface. This is the diagram of the object when it hits the ground. So some important values and data that we can collect from previous calculations is the final velocity is 10.15 meter per second when it hit the ground with the angle 75.14 degree. Some other important values that can be collected from LO1 is actually the final velocity in x component and also y component. In x component, which is Vx1, is 2.602 meter per second, and y component is 9.81 meter per second. So we're going to find out the velocity and angle after this object hits the ground in also two components, in x component and y component. We're going to look into the x component first. For the x component, we're going to use the formula summation of mv1 equals to summation of mv2. Since the value of m will be the same before or after it hits the ground, we're going to cancel off the m, leaving it into Vx1 equals to Vx2. Since we already have the value of Vx1 from LO1, we're just going to plug in the value. Therefore, we're going to get Vx2 equals to 2.602 meter per second. So what we can deduce from this is actually the direction of the velocity in x component is moving to the right direction, while the magnitude is constant with the magnitude before it hits the ground. Moving on into the y component, we're going to use the formula of coefficient of restitution and plug in the value, resolving this formula, and assuming that the value of coefficient of restitution is 0.6, we're going to get the value of Vy2 equals to 5.886 meter per second. So from here is this value, since it's positive value, this direction of in y component is moving upward. Next, the final velocity of the object after it hits the ground, we're going to plug in Vx2 squared plus Vy2 squared and square root the values, getting 6.433355 meter per second, while the angle, using this formula, shift tangent Vy over Vx, plug in the value that we've gotten earlier, and we get the angle after it hits the ground when it's bounced off 66.15 degree. That's all in LO3.
In summary, from our explanation just now, we can see how important and frequent is dynamic application in our daily life. That's all from us, and we hope you guys can get some ideas on what dynamic is in our video. Thank you for watching. Bye!